In this video, we're going to look at radioactive decay and how to balance the equations that describe them. Radioactive decay equations show us what is produced when a radioactive nucleus decays. Remember, an unstable nucleus can become stable by losing some subatomic particles. This is known as radioactive decay. We need to consider three types of decay: alpha decay, beta negative decay, and beta positive decay. Alpha decay is the loss of an alpha particle. An alpha particle is made up of 2 neutrons and 2 protons. They have a mass of 4 and a charge of +2. When an atom loses an alpha particle, the mass number decreases by 4 and the atomic number decreases by 2. So how does that look when we write it in the form of a symbol equation? We can see the mass number decreases by 4, while the atomic number decreases by 2. We can see the mass number and atomic numbers are balanced on both sides of the equations. The mass number on both sides adds up to 238, while the atomic numbers on both sides add up to 92. Have a go at balancing the following equation by finding the missing numbers. How did you do? When an isotope has too many neutrons, it decays by beta minus decay. A neutron changes into a proton and an electron. The proton is retained by the atom while the electron is lost. This lost electron is high energy and is called a beta particle. By losing a neutron whilst gaining a proton, the mass number of the atom remains the same, while the atomic number increases by 1. The equation looks like this. We can see the mass number is 14 on both sides of the equation, while the atomic number remains at 6, since 7 minus 1 equals 6. What about this equation? Can you fill in the missing numbers? How did you do? When an isotope has too many protons, it decays by beta plus decay. A proton is converted into a neutron, and a positive beta particle called a positron. Beta plus positrons have the same mass as electrons, but the opposite charge. The mass number stays the same, but the atomic number decreases by 1. The equation looks like this. Can you balance this equation? How did you do? So now you can see how to balance the equations for all types of radioactive decay.